Hey guys, got some extra questions that have been sent through to me, so I thought I'd put them in a slide and work them through with you. So if you're watching this as a video, don't forget to pause the video, have a go at the question, and then see if your working out matches mine. Okay, so our question sent through to us, a small ball, I love when they do this, who cares what size the ball is, it could be a rhinoceros for all we care, is thrown up into the air. It has a kinetic energy of 15 joules straight away. I want to write up at the top here, kinetic energy equals 15. Just got to shrink my, it'll be recording. Right, now I can write without it looking like I'm falling off the page. And a mass of 15 grams. Now, straight away, I'm seeing grams. I'm thinking, okay, that's not the unit we use in physics. We use kilograms. So I need to change 15 grams. So I'll put M up here for mass. And I know that 15 grams is 0.015 kilograms. Okay, so it's asking us, what is the maximum height it will reach? Okay, so if we're going to convert all of our energy, it has all this kinetic energy, 15 joules, and we're going to turn all of our kinetic energy is going to be transferred into gravitational potential energy. Well, all we need to do is know, well, that its mass isn't going to change. So we've got 15 joules of kinetic energy is all going to turn into 15 joules of gravitational potential energy. So let's have a look at the gravitational potential energy equation. So we've got mass times gravity times height. That's quite handy because we want to know what the height is, and we know everything else. We know that gravitational potential is going to become 15. We know what the mass is, as we discussed that earlier. Okay, and gravity, we're always going to use 10 in Edexcel. Using a different exam board, this can sometimes be different values like 9.81 or 9.8, but we use 10 in Edexcel. Okay, now before I put all those numbers in, I'm going to rearrange the formula. Always good habit to do that first. So first things first, let's get rid of, I want H on its own, let's get rid of M and G. So I'm going to divide by M and G on this side. Now if I do that on this side, I've got to do it on the other side. And then I can cross out my M, cross out my G, and I'm left with H. So my height is going to equal GPE over mg, which is 15 divided by my mass, I said was 0.015, times my gravity, makes it a little bit longer, so 15, so I'm getting my calculator out now. Don't forget to use, this is an opportunity to use our fraction button. Okay, put it all in the calculator in one go so you don't make any mistakes here. So 15 on the top line, on the bottom line I've got 0.015 times 10, and my answer is a lovely, nice, round 100 meters. Well done if you got that right. Let's move on to the next one. Okay, so how much energy in joules does the ball have in its gravitational potential energy store when it reaches the highest point in its flight? Okay, so we've got a tennis ball here, and it looks like we're throwing it straight up, gets to the top, and it's up here. It has kinetic energy of 0. At the top, it's not moving. So it has kinetic energy of 0. Where is all the energy gone? Well, it's all gone into gravitational potential energy. So we could do this the very long way around because we know we've thrown it to a 100 meters high. So if we use the figures from the previous screen, its mass won't have changed. Okay, we now know its height is 100 meters. And hopefully gravity hasn't changed, otherwise that's going to really ruin it for us. And we want to know what GP is, because that's what it's asking us. What's the energy in GPE store? So GPE equals mass times gravity times height. So our mass is 0.015 times gravity to 10 and times 100. Now, it probably won't surprise you, I don't need the calculator for this, because we were kind of told this right at the start. I've got to pause while I was trying to answer this, because if we put that in the calculator, it's going to come out as 15 joules. Now, there's a couple of things you can take away from this. They could be testing whether we know that all the energy is just going to go backwards and forwards between kinetic energy and gravitational potential energy, depending on where the ball is in this flight. It's going to have a different amount of kinetic energy, a different amount of gravitational potential energy, but it's always going to equal 15 joules. It could be, down the bottom here, 1 joule of GPE plus 14 joules of kinetic energy. Or up top here, it could be 10 joules of GPE and 15 joules of kinetic energy. Oh, I didn't get that right. 5 joules of kinetic energy, always equaling 15 joules. Okay, now we've proven it mathematically over here. It's great. It's a good way of summarizing our maths when it comes to solving physics problems. But this question is probably more about, do you understand what happens in a system, that the energy just transfers back and forth between the two. You'd probably find that you could get away with just writing the answer, 15 joules, and move on very quickly. Easy points. So I hope that was helpful to you guys. And if you've got any more questions you'd like me to go through that you get from somewhere else other than ones that are off SharePoint, if you're using something like Save My Exams or Seneca, feel free to send them through. I'm happy to create a video if I think it's a question a lot of people will benefit from, and I'll send it out to you. Hope that's helpful.